I would like to discuss mathematical investigations and the way that we will be doing maths in this course. You will notice that I emphasise the terms doing maths because that's something that children and many of us usually refer to when we're supposed to be engaging in maths, that we do maths. And by this, very, very frequently, we tend to mean that we're doing calculations. And these calculations are then seen as the full gamut of mathematics. And so I want to extend some thinking here about what is mathematics and consequently what you are expected to be doing in this course. And this goes far beyond doing calculations. So what does it mean to do maths? And I'd like to read for you from a book by Van der Waal, a different text from the one you're used to. But in this text, Van der Waal refers to the challenges of popular view of mathematics as a discipline dominated by computation and rules without reasons. And this is often what we see in classrooms, particularly in primary school classrooms, that maths is about figuring something out rather than as a way of making sense. And Van der Waal poses the challenge for us to think about maths as a science of concepts and processes. So not only concepts, but processes that have a pattern of regularity and logical order. So it is a process of finding and exploring the regularity or order within a context and then making sense of it. And by doing so, we are actually doing maths. That is what doing maths is all about. So I ask you to think about your experiences in the past in maths in school, and then your experiences in life where you do maths in life, and compare those experiences as you come to think about what it is to do maths. Is it only those calculations? And to help you in that thinking, I'm going to read from a very new text by Simon, Beswick, Brady, Clark, Farragher and Warren about communicating mathematically, to ask you to think about when before have you actually considered mathematics as a way of communicating. And in their new text, they give us an example from classrooms. And I'm going to read that to you now. It's from page 51 of their new book. Black line masters on which children write their answers are common in mathematics lessons in some classrooms. These are convenient in terms of ensuring consistency in the way that students' work is set out, and they can relieve students of the tedium of writing out questions. However, a necessary part of learning to think mathematically is learning to structure and organise one's thoughts. I'm underlining there, is learning to structure and organise one's thoughts. When students are encouraged to record their thinking in whatever way is meaningful for them, the work they produce will not be uniform and may be more difficult to follow than neatly completed boxes. But it will also provide much richer insights into their thinking and is far more likely to contribute to meaningful learning. In addition, it can be a valuable prompt for discussion of alternative ways of approaching problems and recording thinking. Similarly, working out on scrap paper that is discarded not only devalues the sometimes necessarily messy thinking that goes into solving a worthwhile and challenging problem, but also jettisons a rich source of information about the ongoing development of students' thinking. So many of you who have been a part of Numeracy in the Classroom in 2011 will know how I ask that you do not do your working out and throw it away, that the working out part of anything you do, written explanation of why you're doing that working out and how it happens, is an important part of communicating mathematically. So that anecdote that I've given you from Simeon et al. Encourages you to think about, once again, what it is to do maths. Is it to set things out in boxes? Is it to record something on a worksheet? When maths is such a messy context for us to think within. And so I understand that for many of you, what I'm now asking you to do in this course, to think mathematically, to draw pictures, to guess and check, and use a range of different strategies can be problematic, because in your schooling, you have been so used to doing exercises where a word problem is provided, and as Simeon say, a question is posed, and a visible answer or a solution is looked for. Whilst exercises are often important for us to attain fluency in calculation, they perhaps are not encouraging us to solve the deeper problems that maths can help us to do. And so in this particular course, the strong pedagogy that I am approaching this course with is around problems and investigations. Simeon defines investigation as a situation or task given to a person for exploration in any direction they choose. So in each of the mathematical investigations in this course, there will be many different pathways. What we want you to do is to think, decide upon 3 or 4 different pathways. And that's why you're going to be working in groups, so you can learn from each other what some of these pathways might be. And before you begin the investigation, you then analyse and evaluate which of those pathways will be the best for you. And so in some instances, you will be doing a plus, minus and interesting on each of the pathways that you develop. In the end, drawing conclusions about which pathway is going to be the best for you. From there, you will need to justify that to your lecturer. We're doing it this way because. So justification and verification are important parts of thinking and working mathematically. Asking questions, posing questions are important parts of working mathematically. And so this course is not based upon lots and lots of exercises, though we do want to identify aspects of maths in which you do need to become more fluent. We do not want to overlook that. However, we do not want you working through exercises to be the predominant mode of learning in this course. So as you move through your learning in this course, I'd like you to think about what maths is, how you have seen maths learnt before, and how I am now asking you to learn maths. And this takes you into the aim of maths as being problem solving that helps to deal with complexity and uncertainty that is the world around us. Now that quote comes from Booker et al. 2010 on page 75. That's your textbook that you were using in Numeracy in the Classroom. Further, in Booker, the process for working mathematically, according to Polya, is set out. And Polya gave us 4 stages or phases of working mathematically in a mathematical investigation. He said that first of all you have to come to understand what is it that's being asked for. So you have to identify all the information and select the information that's required and needed, and maybe find out some more information. You have to devise a plan. So rather than after the investigation saying what you did, you have to devise a plan and set that out in the first instance. What are we going to do to work our way through this investigation? Then the process of carrying out the plan. And as you carry out the plan, step by step, evaluating. Oh, this isn't quite working. Where do we have to go back and modify our plan? And so by the end of your investigation, you should be able to draw some conclusions, state a possible solution, state other possible solutions, but also evaluate your own way of thinking. Evaluate your own plan. Did it let you down? How did it let you down? What would you do if you were to do the investigation again? What would make it a better investigation? A more mathematically sound investigation. So as you move into the investigations this term and your lecturers provide you with the investigation, they will not be standing out the front and leading you through the investigation. They will be working with you in your small groups, working with you where your thinking is at, helping you move forward at your pace from where you are at. So whilst some of you face this course with fear and trepidation, I hope you can see that your lecturers will be prepared to work with you where you're at, where your competency is, and move you forward. And for those of you who are already very, very competent at maths, I hope your lecturers will be able to work with you from how you attack the mathematical investigations and elaborate your learning as well. We certainly know that the professional staff we have here in our course are able to do that. Best wishes in your studies, and I hope you will go and read some of the texts to which I've referred in this talk today.